I come again, Julius Sumner Miller. Physics is my business. To some more experiments in electrostatics. We have already discovered that when we rub two things together, mechanically, as the fur and the rod, we can get a separation of charges. Now, in the last century, there grew with a passion interest in these phenomena, and so many devices were built to replace the work of hands. And one of these we have in front of us, an old-fashioned machine called a Wimshurst, W-I-M-S-H-U-R-S-T. I'll write that name on the board, perhaps. Also called a Töpflerholz. These are names bearing the names of the men who designed them. Now, I cannot, because of the shortness of time, explain how this business works, but its results are staggering. Oh, yes, and I'm constantly forgetting to introduce the men on the show. The boys are from the Marist College again, the Marist Brothers College, and we have again the man with the freckles. Greetings, sir. And you, Winton, my pleasure to have you. So here is a machine which can be turned by hand and equivalently does the work that I'm doing here. With the result, the charges are stored in two devices here and here called Leyden jars, L-E-Y-D-E-N.
Professor,
yes?
What kind of fur do you use?
Oh, well, here, this is cat's fur, or dog fur, or rabbit fur. So now, the machine separates charges, with the result that one of these knobs becomes positively charged and the other negatively charged. A great difference of potential arises, much more than I can get by hand, and a tremendous spark can be made to pass from knob to knob. Let's see how this does it. Mr. Anderson, come forward. But before we do that, let's get a view of my man Anderson. And I am reminded at once that Michael Faraday had an assistant whose name was Anderson, who was charged with great responsibility and executed his responsibilities with uncommon care and diligence, and I could say the same of my Anderson.
Thank you,
Ray,
Professor.
let's notice, I don't want to run the risk, you run the machine. Anderson is turning a crank, and now he has turned on an electric motor. Look at that. Fantastic. Further separation. Further separation. Notice the energy in that spark. Fat and blue. Very good, Anderson. Will you shut it off? Thank you. Notice what we are led to say. Isn't that machine a powerful thing, eh?
Yes.
Notice the energy that's available. Now, that machine has only historical interest to us, but it is good for young people to see what the geniuses of the last century were able to make. Now, let's go to the blackboard, if you will take your seats again, and I will say something about that. Wimshurst or Töpflerholz. H-O-L-T-Z. Now, you noticed, men, on that electrostatic machine that we had some spheres here separated by a certain distance, and then a spark passed between them, right?
Yes.
And I am prepared to tell you this, that if these spheres are about 1 inch in diameter, which those are, and if the spheres are separated by 1 centimeter, which is less than half an inch, the potential difference in dry air is 30,000 volts per centimeter. Isn't that fantastic? That's fantastic energy there. 30,000 volts. So when you see then, when we had it separated 4 or 5 inches, don't we have 200,000-300,000 volts difference of potential, right? Now, you may remember that in my introductory program, I said that I would ask some questions and answer some, but that I would also ask some which I would not answer. So I'm going to ask 2 questions which you can take up with your master in science. Did you not hear the spark when you heard it? right?
Yes, yes.
So you heard something, H-E-A-R-D, and did you not see something?
Yes.
Yes.
And I want to ask, have you not seen sparks before?
Yes.
And have you not heard them before?
Yes.
And I want to know exactly, what are you hearing? That is, what made the sound? And what are you seeing? That is, what made the light? And these questions are very difficult, and that's why I don't answer them on the program, you see? So, we have explored, ladies and gentlemen, an old-fashioned device for doing work to separate charge. Now, on the next program, I'm going to show you a modern device, more recent, within our own time, which does the same thing in a much more elegant way. So I thank you for both. Do you have a question,
Yes.
Winton?
I noticed Mr. Anderson rubbed the thing,
The two plates?
Yes.
Yes, that's a good question. You see, sometimes the machine does not work at once because it may be a little damp or the like, so he primes it in a fashion by rubbing it with a fur. That was a very good observation.
Professor?
Yes.
What do you use that for?
Oh, just to have fun with. That's all. You see, why do I work in physics? Because I have fun with it. Very important feature of a man's life. See, just fun.
And
Why do I
the-
look at the sky? Because it's pretty. You see?
What do you use those beads for?
Oh, those beads. That's a good question. These beads are amber. That's the pith. That's the sap of a tree, which exudes and lies on the trunk of the tree and then hardens. And this, in fact, is the very stuff which Thales explored in the 5th century BC. Because, to quote him, as the records show in Herodotus and Pliny and Thucydides and other historians of the ancient Greeks, Thales wrote, "I have observed that when amber is rubbed, it acquires unto itself the property of attracting light bits of straw and dust." And if you read this in the Greek, it sounds very pretty. So, it's time for us to go. We shall return, ladies and gentlemen, another time with more explorations into the forces of nature.